So what is fusion? What is fission? Let's start off with fusion. Fusion is when you take two smaller atoms and you combine it into a larger single atom. Fission would be the opposite of that, where you take a large atom and you split it into two smaller atoms. The concepts are pretty simple, but there's a lot we can do with fission and fusion. An example of fission at work would be in nuclear power plants. So in nuclear power plants, uranium undergoes fission and turns into smaller atoms like krypton, barium, plus a few extra neutrons. So nuclear power plants, they take rods of uranium, they submerge them in water, and then cause them to undergo fission. This fission process gives off a ton of energy in the form of heat. Water goes around these rods and it takes in the heat that's given off. Then the water then goes on to turning into steam, which powers turbines, which generate electricity for use. An example of fusion at work we can see every day when we look outside. The sun is the biggest fusion reactor around here. Inside the sun, gravity forces hydrogen to combine to fuse together, creating helium. This fusion process also gives off a lot of energy we feel from light and heat every day. So you may, or may not, be wondering, where does the energy come from? Why does fusion and fission generate energy? How does it generate energy? The answer lies with this lovely equation. E equals mc squared, the mass-energy equivalence formula. What this formula tells us is that mass and energy are interchangeable. So in fusion and fission reactions, you have atoms with protons and neutrons. The atoms you start out with and the atoms you end up with, when you total them up, all have the same amount of protons and neutrons. So you start out with the same amount of protons and neutrons as you end up with. However, in fusion and fission reactions, if you take the atoms you started with and then you weigh them, compare that weight to the atoms you ended up with, you find out that the atoms you ended up with often weigh less than the stuff you started out with. So where did that mass go? That mass was turned into energy, which is the energy that was given off. So in nuclear reactors, when uranium splits up into smaller atoms, the mass that is lost is the energy that is given off in the form of heat. In the sun, when hydrogen combines to create helium, the energy that's given off is the energy we feel from in form of light and heat. So you may be thinking, okay, we can make energy using fission in nuclear reactors. Can we make energy using fusion, kind of like how the sun makes energy using fusion? The answer to that is not really. So inside the sun, gravity is what makes hydrogen fuse into helium. However, on Earth, we don't have that kind of gravity that the sun has. So instead, we have to utilize other methods to make fusion happen. So we can do fusion on Earth. The thing is, it takes a lot of energy to cause fusion to happen. More energy to make it happen than we get out of it. So it's not a good source of energy because it takes more energy than it gives us. Now, there is a concept called cold fusion. Cold fusion is like normal fusion, except it doesn't take a huge amount of energy to make it happen. Normal hot fusion takes a lot of work to get going. You need a huge amount of pressure and a temperature that could be millions and millions of degrees to make fusion occur. With cold fusion, you wouldn't need a huge amount of pressure, and you would maybe only need a temperature of around room temperature for the activation to occur. So you may be thinking, wow, cold fusion sounds great. Why don't we use that? Well, it's because we don't know how to. Cold fusion hasn't been invented yet. In fact, we don't even know if it's possible. A couple decades ago, we thought we were able to invent cold fusion, but it turned out to be a false alarm. Cold fusion, if it's real and if it's invented, could change everything. It would be cheaper, safer, more convenient, and more efficient than today's nuclear power. If it exists, cold fusion would be like the holy grail to nuclear physics. So, why did I decide to make a video on fusion and fission? Well, the reason for that is because I find nuclear physics to be an absolutely fascinating field of study, and is a field of study that I'd be very interested in pursuing. While it does have its faults, I do believe nuclear power is a great source of clean and efficient energy. And cold fusion, while I think it sounds a little too good to be true, I'd be very interested in seeing that concept becoming a reality.